Engage. I'm your captain, James T. Picard, and welcome to Streaming from Here. I'm just kidding. I'm Victor. It's Wednesday. You at the Confluent Developer YouTube channel, and means that you are at the Streaming Frontiers. I will be your captain today to go where no data streaming engineer has gone before. And we're going to be talking about some stuff around Kafka, stream processing, Confluent Cloud, and some other things. But before that, as always, let's figure out if everything is working. If you can see me the same way as I intended you to see me. So let me quickly see if there are any activity in the chat. Let me see where's this window with the chat. And I can see anyone is coming. So, as far as I can tell, at least one person is watching. And I hope we have a connection in 2 channels. We're watching this on YouTube in Confluent Developer YouTube channel. And also, you watching this in LinkedIn. At the LinkedIn, we do have a Confluent page where everything is happening. So, let me quickly check and see if the LinkedIn is also live. Yes, LinkedIn is also live. I'm extremely excited. And I don't see, for some reasons, comments coming from LinkedIn, which is weird. Please comment in YouTube. Please comment in LinkedIn, and we'll see if this actually works. Now, I see if I went to directly to LinkedIn, someone is asking where's the recording of the first part. That's the good question. Recording of the first part, as always, you can find in this beautiful channel. Confluent Developer YouTube channel. That's your place to learn all things Kafka, to learn all things stream processing, to learn everything about your favorite technology in the world of data streaming. There's a tab called Live, and all the previous recordings are here. YouTube, you can find this here on YouTube. Okay, all right. Okay, let's see if we actually can see some reactions. All right, Mini from Bay Area. Great. Toby, welcome to Streaming Frontiers. Thanks so much for being with us. James, this is awesome. It is working. There's some people who are reacting on the live stream, which is great. Technology working, and I'm extremely excited. Now, quick announcements as always. Quick housekeeping items. Now, let me remove this. Yeah. Current 2025 pinnacle event in the world of data streaming. It comes to New Orleans this year, and it is the 3rd event of this humongous data streaming event world tour. We went to Bangalore earlier this year. We went to London, and now we are coming back to United States. New Orleans, October 29-30. Book your tickets. Ask your friends. Ask me. Shout out. Go into slide into my DMs and ask me if I have any special discount for for this event, and I might have something that would be interest you. So, current 2025, all speakers already received their acceptance emails. We expecting get some confirmations, and we can start building agenda. I think we can see some of the people already here on this web page, and we see some familiar faces. Let's see if yours truly is here. Yep, yours truly is also here, and I will be talking a lot about schema registry and how to build polyglot applications with schema registry, with Kafka, and different languages, not only Java. Many of you know that I'm a Java buff and building everything in Java. But in this particular session, everyone will have a little bit of this. There will be Java, there will be Python, there would be a little bit of JavaScript. So it's going to be good. It's going to be good. And stay tuned for more announcements. And yeah, another thing that I really want to mention, for you folks, if you want to meet me somewhere in person, this is going to be a great opportunity. So September 11 in Minneapolis, Minnesota. Mark your date. This is going to be a hands-on experience. So I was developing this new workshop that allows you to quickly start with Confluent Cloud and focus on solving your problems rather than just struggling with infrastructure or like building infrastructure or running things in Docker and all these kind of things. The goal of this workshop is teach you how to focus on solving your streaming application the tasks if you want to be very proficient on solving streaming problems. We're going to talk about Kafka Connect. We're going to be talking about Flink in Confluent Cloud. We're going to talk how to deliver results out of this in the form of Tableflow. It is going to be very intensive, 2 hours. It's going to be 2 hours, but there will be a ton of information. And the purpose is that to teach you everything to get started so you understand the benefits of the platform. So great opportunity to meet Viktor if you are in this area. Also, if you want to have this workshop and you know someone who can sponsor, say, venue, and invite some other people, let us know. Let us know because it is possible that this workshop will come in city close to you. All right, so let's see what is happening here. I see there's some activity in our chat. I see something is not very. All right, Santosh from India. Welcome to Streaming Frontiers. Yeah, so we tested LinkedIn. LinkedIn works great, and I know that it's probably the best social network that we have right now with all these nice features and nice people. Everyone is super polite to each other, and everyone discussing opportunities and what Kafka Streams taught me about B2B business. All right, now, all right. Let's get to the subject because today is going to be very intensive. It is going to be very, very intensive. Now, the previous presentation and the previous stream, we start talking about a subject of how to query a stream. I spent a little bit more time explaining why this subject is important to me, and I think why it is important for many of you. And as a second part of this presentation, we're going to go up the hills. We're going to be increasing our stakes every time, every new stream, and maybe by the end of the year, that's the plan, by the end of the year, somewhere in Christmas episode, you will have everything. We will cover every tool, we will cover every technology, and on the previous episode, I will remind you where you can find all this code and stuff. It is my GitHub page. And there's a repository 1, does not simply query a stream. It is still a work in progress. There's a bunch of things is not working, bunch of things is working. There's a lot of things that I plan to do, a bunch of things I was not able to do. So last time we look into how you can use things like Kafka Connect and connect to whatever database to get the dump of the data, and after that do the processing. So I showed you how we can run this with Kafka Connect. Kafka Connect was connected to my Confluent Cloud account, and my another approach I showed you is to use tool called Kwack to do with query things with what is that? DuckDB. So let me quickly show you where we were departed from the last time. Let me make this a little bit bigger. I'm gonna go with the edit session. We're gonna do live streams. Boom. Now, one of the things that I wanted to show with the Kwack is that how I can connect to my Confluent Cloud, get the data. Data was in Avro format, and after that, using DuckDB, I will be able to run queries. So, in this particular case, Kwack will connect to my Kafka topic, get the data, figure out the schema format, and after that, spin up the DuckDB instance. And again, all this like wiring and all this code will be there in here. Very important, very important thing that I always keep forgetting, and thank you so much that someone reminded me. If you are, like now you can see this, like with the power of, computer science and stuff. If you are interested in play around with Confluent Cloud and, do your thing in Confluent Cloud, please go and check the sign up button. There would be some discount code and stuff like that. I think there's a ton of data right now in this, so that's why it's kind of like struggling to get all this data back to my computer. I will give it a moment while it will be getting data in. While we wait. Now, this next thing is that I would like to talk about is Kafka Streams. While we waiting for Kwack to download all these messages from my cloud. Now, Kafka Streams, it is a library. It's a library. It's a library part of Apache Kafka implementation. It's a Java library. Has some Scala API. And I don't know if anyone is using this these days. So with Kafka Streams, you will be able to do multiple very interesting things. So we discussed last time when we talk about this how to query stream about two type of streams. One type of stream is where we interested in particular record, that what we would called operational or OLTP type of streams, but we're also interested in OLAP streams where we need to talk like bigger story. And when I will be talking about Kafka Streams today, let me quickly show this. Okay, we're gonna talk about this particular slide. Where's my screen? So let's talk about transactional use case and the simplest possible use case. Now we have this Java framework that has a very intimate connection to Kafka. What does it mean? Some of the design decisions about API, and I will show you in the code in a few seconds, were highly inspired by the way how the Kafka structures data. Obviously, in the Kafka Streams, we do have a concept stream and table. And with the streams, it would be one-to-one representation of data that is in Kafka topic. Kafka Streams has a lot of inspiration from traditional. Let me see if I show this in the full screen. Super annoying. In the Vino place. Yep. Yeah. I like to show this in the full screen. Now, we're ingesting data directly in the topic, and API also very inspired by Java util streams, where we dealing with collections and we perform certain operational collections. Similar like feeling of API. The concept of key table exists in order to preserve some of the local state. And the key table will represent kind of like a point in time state of this particular topology. The thing that will be responsible for your data transformation called topology, and we're going to be dealing with this. The key table forms a key value store. Again, also very much inspired by the Kafka message structure, because we do have a Kafka key in Kafka message, the key in value, and we will be able to get this key value store on Kafka Streams. Now, when I was talking about the intimate connection with Kafka, it does have same underlying technologies, consumer groups, and all the things that exist to scale things in Kafka. And we're gonna see how we're gonna read those things from the state store. Again, remember, we're talking about not just the processing, we're talking about querying the stream, getting some data out. We want to get the applications, get this data in somehow. So we're gonna look into interactive queries in a second. We're gonna start with transactional because it's simplest thing to grasp and simplest way to understand. So let's dive in. Where's my little helper? We start with something simple. And in this particular case, we're gonna start with traditional word count application. By the way, comments section. Let's make some noise there. What version? What theme of IDE you prefer? If we're gonna go with, say, black theme, or we're gonna go with white theme. Let me know in the comments. Where's my theme that I prefer? Vivid, yes. I prefer white, but let me know. Maybe for the stream this would look better. Also, YouTube, why I don't see your comments? YouTube, let's make some noise. So when I was talking about Kafka Streams, I mentioned this thing called topology. And topology, it is will describe black theme. Okay, black theme it is. We're gonna do a poll at the end of this presentation, and the next time, and we decide which theme would be better. Now, so topology describes how the data flows in and out of the system and what is happening with the data. Remember, those stream processing systems, they're not dealing with data in bulk, comparing to Java util stream where you have a collection. But in Java util stream, you when you start building your application, you're actually dealing with one message at a time, one event at a time, and things like that. Now, in this particular case, what we're getting, input topic that will contain some random text data. I want to, obviously, for many of you, but not very obvious for many other people, we're going to use the classical example of word count because it's easy to explain, easy to implement, and also it has a lot of interesting things like preserving the state. So, first of all, let's see if I can visualize this. First of all, Kafka. Where's my? Well, let's do this one. we're gonna do topology.build, and we're gonna do build.describe. And this will help me to explain what is going on here. Now, this application, it's just simple Java public static void main application, as you can see here. If I go to main, we connect to Confluent Confluent Cloud. Push some and start reading some data. And after that, we also need to create topics, blah, 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 all these kind of things. But most importantly, that we need to create topology. So what's gonna happen with our application. And after that, with this topology, we will be able to see what is happening. Now this is the time to run this application. And we're gonna see if it actually works. Always something interesting happens. So first of all, remember I was giving a topology description. So let's take a look on this first before we jump into solving some of the things. I'll explain how the things work and how the things would just give me a smaller version of this so I can copy. And in order to visualize it, I have very cool instrument. It's called a Kafka Streams visualizer. I fork it, add a little bit more style to this, so I can have a little bit more, much cooler representation. So now, when I call this method topology.describe, so it gave me a textual description of this topology. I will paste it here, and when I click the convert to image, this is what I get. And this is what transformation of the messages would look like in Kafka Streams. This topology is represented by direct acyclic graph, meaning that there's a beginning, there's an end, there's no cycles, and everything is sequential. And our message from our movies topic will traverse down into something. And this something is actually described in our code. Specifically, this. So first of all, we want to run this flat map values. We get the sentences with some text. We want to turn them into individual words so we can start counting those. There's some suggestions came into the Darkula theme is the best. Let's see if I can do Darkula. It's not bad. Actually, it is not bad. It's too white. It's terrible. Darkula, colorful, and not colorful. Let's do a regular one. It looks like it's a little bit more colorful. Though I'm not digging the font. I think I need to change the font for this again. Now we have a Dracula. We have a Darkula code. While we're doing this, Ivan, welcome from Brazil. Wow, great! Thanks so much for joining us. Now, we're getting this message. We first of all. Oh, sorry about that. Something swapped. I have a movie producer, and I also have this nice tool that allows us to see messages in Confluent Cloud. Let me quickly log in to my account. It's always a little bit cumbersome when you need to log in and like, oh, don't look at my passwords. There's a cluster, and I submit movies. So the movie information, it's pretty simple. It just has information about movies, titles, and some information about genre and all these kind of things. it really doesn't matter because we're going to be counting, numbers. We're going to counting numbers and we're going to see all these things here. Now, we need to take one individual sentence. We need to parse it. We need to go from separating things and extract individual words. And after that, we're going to get, you guessed it, we're going to get another stream. Movie count. Specifically, a result of this flat map, we're going to get another stream that will include words is our stream. After that, we need to start grouping by. So now we need to pick up the words and start grouping them because we want to count words. In the result, we want to have a word and count, word and count. Result of this count, we can store inside this materialized state store. Oh, I'm not showing this yet. My apologies. So from the flat map, we parse this. We're going to get another stream of words. We group this by key. In this case, key is going to be our word. And we're going to get like word key value. Now, next thing is that we're going to start by this helper method will allows us to count the values for particular key and store it inside this state store. Same thing you will be able to do here. So we get the result. This is our Kafka Streams. We perform flat map. We select the key and we did a repartitioning. So that will create additional topic with the right partitions. And result of this repartition also will be sorted in case of some of the failures would happen. So we don't need to repartition this again. It will pick up where it left off. Now from this repartition source, we can start now doing aggregation. So we're going to store this inside a key table, which is in memory. And word count store, it is actually like a small database. It's going to be our RocksDB instance that will be available for query. And the results will be placed into movie out. So if I'm going here and let me run a producer so you can see some of the action is happening on the movie out, and I would start not from the beginning, from the latest, and let me see if I will be able to run movie producer. Also will write some data into Kafka topic. Waiting for messages, and we should see the messages just in a second. Again, it goes into cloud, from cloud. Yeah, supposed to be sent all the messages. Not out, my apologies. We go in here on the movies. We updated movies. My Kafka Streams application should be able to, like, we're already processing value. See some of the results already placed. And we need to get movies out to get results. So this is how this would look like, because we're going to have different keys. Well, for example, detective, and this is going to be number. I'm not putting any schema here. So it is just the bytes, and the way how this extension will understand this, I don't know. It's not something that useful for us to query. So what we want, we need to have some sort of ways how we can get these results. And for this, what we're going to do is we've wrapped this state store that we used in our application, this particular state store, and we can expose this to the REST API. That's what we called in Kafka Streams world interactive queries. So in this case, I have this small embedding library called Javelin that will run the web server. So inside my Kafka Streams store over here, I will be able to get information about this word count store and expose it to outside world, so I can call this through different APIs. So in this particular case, we're interested in words. Meanwhile, our in-memory thing is ready. So if I'll just do HTTP port 90, what was the port? Is 9091 / words / what word we're looking? Detective. So So in this case, that's what we get. That's our database. We build a database on top of Kafka Streams. We will be able to get this information. But here's the kick. In order to query this data, we need to know what we're querying. So first of all, there's no kind of like ability to query based on the random fields. We only need to know key. So in the way how it works in the implementation wise, it is in our case, state store, if we're getting some word, we're getting either a result from the state store or there's nothing there. So if I would do something like, I'm pretty sure there's no Victors there. Word not found, the error was found because there's no key in our state store that has a Victor in it. We might have something like hello, and we see this hello appeared 16 times. Now, the cool thing is that it's a library. You can build, embed this in whatever application you have, embed in any Java application, but it is a library. You need to build a lot of stuff yourself. So in this particular small case where we just dealing with simple word count, that's the logic. That's the logic what we do. And this logic is pretty short. We do have it, maybe like 10 lines with comments if we want to have this nicely parsed and things like that. But rest of the stuff is ceremony. Let's call it like that. I know people like to throw their complaints. Complaints will be received in a written form. Otherwise, they won't be received. There's a lot of ceremony. There's a lot of ceremony because it's a Java, it's a framework, a library. You need to do a lot of things. So there's no built-in web server, and it is not opinionated. So we talk about this. It is kind of like OLAP, OLTP stream. We have individual records, and we can count these individual records and doing something for this. Now, the next thing is that I want to talk about is our the analytical use case. Now, for analytical use case, again, there's a Java API allows you to do all things. Meaning that if it's Java, you need to know what you're doing. Key table I just showed you, and this is important. Every time you need to implement new query or new pattern or new use case, you need to build your own topology. Which means that it needs to be either complicate existing topology. You can have like sub topologies. You can have multiple different topologies within one topology, but in general, it will complicate things. And we use iterative queries to do some analytical stuff. So let's get to it. If you remember, by the way, let me refresh you on some of the things that we did. The last time, since my DuckDB was able to recover. We do have information about flights, and this information is stored inside the Kafka topic. And say, if I'll just do something like this. So in this case, we'll get information about the overage delay per airport or per route. So we do have different routes between different airports. We know how many flights were taken between those routes because we were able to look into flight information, and we group this by origin and destination, so we can have ability to find how these flights will be correlate. And we get overage delayed in minutes. And this is what we can do with our Kwack, DuckDB, SQLite, Postgres, and all these kind of things. Then if I want to implement something similar, like say flight delays, let's see if I have a delay. Another use case where it's the total flights per airline and how many delay flight and what's the percentage of this This information is totally fabricated and fully generated just in order to demonstrate and I'll have a data pump. But it is not how things are in reality. I hope. Definitely not United because they're pretty good. They treat me pretty well. Now, if I want to implement something this with Kafka Streams, how would I do that? Now, I do this in another use case that you can find this with my flight application. So Kafka Streams, let's start with this, handles a lot of, can handle a lot of things that you will not be able to either do it yourself or you need to spend a little bit more time implementing this. Let me see if I can view. Can I do? Yep, the Zen mode, the nice and big. Many people asking me like why I need to use Kafka Streams if I can just write producer and consumer. Yes, you can, but you need to write even more ceremony that you were you would need to do with Kafka Streams. Now, slightly different use case. So now we know how we know this, because I do have this flights information inside my Confluent Cloud, and I know that my flight information, it has schema. In this case, it has Avro schema. So we take this Avro schema into my local, and we create a Java Pojo. Technically, it's not entirely Pojo. It has a lot of things related to Avro specifically. So if I go to this flight object, it has built-in schema. It has a lot of things to deal with the Avro, different schema configuration. Again, this is schema talk. I will be talking about this stuff in details in New Orleans in end of September. End of October. End of September, we're going to be in Minnesota. Now, we're getting this information from Kafka topic. Now, this Kafka topic, in this case, flights, where's the flights table? We're getting information from flights topic, and we're specifying how we can read this data in what format. Since we do have a schema, now we need to define the serializer, deserializer, and also key also would be deserialized. So now this is the first step. Second step is that we wanted to have a similar use case that we had with the word count, but even simpler. We want to have a flight information, latest and greatest value, available by flight ID. That's what we're going to do. So in this case, we're creating this, the materialized state store called flight store, and we're going to be querying this flight store based on flight ID, whatever. So this is how we're going to be taking care of our analytical side of things, like key value request. Now, next thing is that we want to learn a little bit bigger story from this data. So in this case, we run this group by situation where we want to basically re-implement the similar query for here. We're going to be capturing total flights. There's methods to do this aggregation. They will manage state store. They will manage all this underlying machinery. So if you will be implementing this yourself, I'm telling you, you will spend more time fixing your bugs than actually implementing this functionality. If you're doing Java, if you need to do any stream processing things, and you need to do something simple, you're not ready to jump and learn Flink. We're going to talk about Flink in future episodes. Kafka Streams is still very good tool that you can implement yourself. And the API is fantastic. and it's easy to use. Like, I don't know, like this code looks nice. Now, and also we also will see a topology. So let's run this application and check our topology. Let me run down this smaller. Our topology would be printed out somewhere here. Can we see the topology? I don't see it. Let's see. Yep. So multiple topologies. Let's take a look how this application would look like. Remember, we're gonna do multiple things here. We're gonna do okay, it went too much into Zen mode. Too much. Now we're gonna go back in this topology. We're gonna convert this to image, and now, so this is how it would look like. Very similar to what we did in the previous step. We pick up the right key, and we created a keyed store where flight information can be retrieved by key. Now, this this allows us to also implement something that I call a delayed by origin flight store. And I'm using the same approach. I'm using the same approach that I did for this application. Only difference, I think I have chosen different port. That could be. Let's take a look. We're gonna look at the start, and no, it's gonna be port 90. And I'm gonna just do something like HTTP and flight, something like this. So I need to know flight information in order to retrieve it, latest and greatest value. That's great to solve our OLTP use case. When we care about individual record, we know this, and we're gonna run this. Now, what if we need to get information that we don't know flight? That's the problem. Because in this case, we need to maintain somewhere the lookup table so we can get all information about all the flights, and after that we can go and drill down. So in this case, you need to implement this type of functionality, kind of sort of yourself, or it still can be a part of your kind of REST API, but you need to do a lot of things in order to implement this. So for now, only thing what I do here when I need to get information about flights is simply to use this flight store. Now, what about this next thing? I want to go get information delayed by airport, and say, let's see, SFO delayed flights. If I'll just go here, San Francisco, delayed flights. Also, I need to know airport. So in this case, I will get information about SFO delayed flight. Now, if I want to get like overall picture, again, getting into this delayed by origin store and need to do iterator over the store, get all this data, and push this data into say airports delayed, and it will gives us kind of this nice breakdown per airport. Also, because again, it is my Java application, I was able to even build something cooler like this this UI. So congratulations, you build your database. But this database would be very specific for this use case, very specific to particular thing that you're trying to implement. If you're trying to be very generic, you will get into some trouble because again, you're trying to reinvent or you build creating your own creating database. There was an idea. I don't know if I will be able to find some information about this very cool piece of technologies that called ksqlDB. So with Kafka Streams, we were struggling to, if we need a new use case, we need to implement this use case in our Java topology deployment strategy. We need to figure out how we're going to be building and packaging this application, and after that, deploy this somewhere, make sure the life cycle is running. Next thing is that we need to make sure that results would be consumable in one way or another, so we need to wrap this in certain API. I didn't mention this when I was talking about Kafka Streams. So Kafka Streams is not enforcing you to use any type of protocol for building this system. There's even some API that allows you to build distributed Kafka Streams application with the interactive queries also kind of like distributed. But in this case, you need to build some sort of aggregator that will be collecting results from all the nodes. I did this in the past in a few other episodes of, I forgot how we call live streams. We call it live streams, not the streaming frontiers. There's a lot of cool things that you can do with Kafka Streams if you're enjoying this. If you need to solve the problems, people will start asking questions. Hey, what about there would be something that exists and help us to wield the power of Kafka Streams, but in more user-friendly way. And this is bridge. This is going to be bridge for the subject that I will be going deep details on the next episode. But this is, I think, in my mind, it sounds like a cool bridge that can bring us from like in-store brands like Kafka Connect or Kafka Streams. In-store, I mean like it's a part of Apache Kafka, into the something that is gaining popularity and gaining momentum, and streaming databases. So streaming databases, I even have a picture that will kind of streaming SQL, streams, logs, and there's something that will be catching these things. This is going to be like very quick here, because I really want to dig into this subject the next time, because there would be plenty of things to explore. There would be different technologies to dig in. Now, ksqlDB use Kafka Streams as an engine to run this computation. It's hidden, so you are operating with SQL. And I want you to pay attention, because this is very important. When I will talking about streaming SQL databases, there will be some distinct features that I really liked how I read this in streaming databases book, but also I solely support this myself. First of all, queries needs to be written in SQL or SQL-like language that allows people to not focusing on Java or Scala, God forbid, or something else. Next thing is that we talk about Connect. Connect is a brilliant technology, allows to connect multiple different sources. So this, we take a Kafka Streams, we'll take Connect, we build them together, we're adding SQL, we're adding deployment strategies, so you don't need to worry about, say, you run this in a container, and after that you ship the list of SQL statements that you want to execute, and now you're deployed. That's how it's simple. Or in the past, there was a managed service in Confluent Cloud that allows us to do this, but we're not talking about this guy anymore. There's better ways. And obviously, we want to have ability to materialize, use, do not reprocess the things. So what will happen with, say, this application, if I will kill it, you can see there's still, I don't know if you will be able to see. Let me try to zoom in this in. No, this zooming is not working on the stream. So essentially, let me try to do this one old school way. Why I cannot do this bigger? Yes, I can. My flights information, and you see there's all these streams, flight streams, flight store changelog. Remember, in our flight store, it will run locally, but Kafka Streams allows to replicate this store through Kafka. So in case of failure, in the case of one of the nodes we're gonna die, we have this information stored inside the Kafka in the form of changelog topic. This is very cool. Again, it's already implemented. You can try this yourself. Here's the problem, though. This is something that needs to be implemented. With Kafka Streams, we provide this way. With Kafka Streams, with ksqlDB, we have ability to hide all this complexity behind. And what's a great idea? It was a great idea at the time that allows us not only run this processing part, but also execute push and pull queries. Say one the query that I will be constantly getting data. It's gonna be my the pull query. I'm kind of like calling this. And also, my application can be reactive. So, say I can subscribe to some pattern and constantly meet results. And in this case, my application will get the results. So it was brilliant. It was a cool technology. And still, I think you will be able to run ksqlDB, I guess, in Docker. Not sure if it's still available as a part of stream processing packages inside Confluent Cloud. But you still will be able to run this with the local thing. I need to check. Unfortunately, this particular technology was super advanced for its time, and I'm just kidding. There was some limitations that you need to know about this. Now, Kafka Streams, ksqlDB consumers, they highly rely on consumer group topology to scale this, application structure. You scale your queries only up to number of partitions you have inside your topic, and also this state store. When we're dealing with the big applications, because of the different reasons, this state store can be really big, and you need to implement different strategies to clean up the state store if you don't need this. If you don't need to get all this information all the time. And in general, some of the massive use cases start struggling, especially with the, there are some ways how you can optimize it, but in general, the massive amounts of data, terabytes of data in the state store might be, not super shiny thing that where the Kafka Streams will shine. So it's not something that probably would be useful to do. So, but we're going into route of streaming databases. So next time, in the next episode of Streaming Frontiers, you'll learn what is streaming database, and how it works. How we can use SQL for queries. We're gonna use streaming sources as a first-class citizen. Obviously, it's gonna be Kafka. There's a persistence in storage that allows us to execute queries on top of the things. We touched a little bit of ksqlDB. We're gonna talk about some other interesting technologies that I'm super excited to dive in. And how they will implement those pieces of functionality. I hope you like this episode. I hope you like this breakdown of how to use Kafka Streams. Again, you can find source code in this repository inside my GitHub. You can find this one does not simply query stream, and you can subscribe to Confluent Cloud get access to your Kafka, your own Kafka cluster with the tons of topics. You see, I have all the topics that I have. There's different information. We're gonna touch some other different things. We're gonna be talking about the Flink in future. So it's gonna be cool. It's gonna be cool. Try Confluent Cloud. Try to run this demo. Let me know how it works. Most importantly, because without your feedback, it's very difficult to understand if you found this useful or at least entertaining, or at least you spend this few moments of your life with me today. Thanks so much for everyone from LinkedIn. I see as of right now, like over 30 people were participating in the stream. We did this in YouTube and LinkedIn. Subscribe to YouTube channel in Confluent Developer. Follow us in social media. Follow me in social media. There's Blue Sky, X. Hit me up in LinkedIn. I hope I'll see you in the next episodes, and next month. Maybe a little bit earlier. I need to check my schedule. But with this, my name is Viktor Gamov, and as always, have a nice day. I'll see you in the next one. No, I will see you in the streams. I think this is gonna be better. I'll see you in the streams. So bye. Whee!